So the last thing we're going to do with the chi-square distribution is look at one more example of the goodness of fit test. So we're looking at testing one variable to see if it fits the given distribution. The second example for the null and alternate video was when we looked at Joe Betts and his thoughts on the horse races. Joe Betts thinks the closer a horse is to the inside of the track when he starts a race, the better chance he has of winning. Below we made a list of the chances of the horses have of winning depending on where they start. Test shows claim at 99%. So the first thing we did was null and alternate. The winning horse's position fits the assumed distribution. At least one is incorrect. So there's our null and alternate for this. And the important thing to point out is this is not equal. We did not use the term uniformed or evenly distributed. We are looking at just different percentages for each one. Since it's not just all the way down equal, how we find our expected value is going to be different. So let's go do that now. Okay. Remember finding our test statistic to get the p-value. The formula was observed minus expected squared divided by expected, and everything, the summation adds everything up. Okay, so we're going to do this same process of finding the expected values and then going to the calculator to use the shortcut. But this time the expected values are going to be found a little differently. This time, since it's not equal, we need to do a little more work. So we need that expected value list. So you still find the total, adding up all the observations. We got 235. Now instead of taking 235 and dividing by 8, that would be saying that everyone has an equal chance. We don't have that. Everything has a different percentage. So now you do have to take the time to take each percentage, multiply it by the 235. So 235 times 0.3 for the 30% is 70.5. 235 by the 15%, by the 14%, and you're just going all the way down to the 5% and getting each one of your expected values. Okay, so there you maybe go through, type a couple in, make sure you're getting the same expected values that I get. And there's your two lists. Your observed would be your L1, your expected values is your L2. And the other thing we needed was our degrees of freedom. Degrees of freedom is n minus 1. This time there are 8 categories, or in this case 8 positions. 8 minus 1 equals 7, so there's our degrees of freedom. So now I'm going to go to my calculator. I have my L1, L2, and my degrees of freedom needed. Go to the calculator, stat, edit. I'm going to clear out my list from last time. So give me a second here. This is where you can take your chance to plug in your own lists. I'm going to plug these in. 50, 42, 41. Taking your time making sure the numbers are plugged in correctly. So there's my observed values. Here are my expected values. Now I rounded to 2 decimal places for these, as I would suggest at least 2 decimal places. Definitely do not round to just a whole number. And the last one, I'm just going to double check my list real quick, make sure they are correct. Alright, both lists are good. So now I'm on a second quit. The L1 was my expected, the L1 was my observed, the L2 was my expected. I'm going to do second stat, go over to math. This is going to get me to the sum function, number 5, parenthesis, L1 minus L2 parenthesis squared divided by L2, close parentheses. That's my test statistic for formula. Summing all of it up, hit enter. 14.269. I'm going to round that to the 9, so 14.269 is my test statistic. For the p-value now, second distribution, and I'm going down to number 8, the chi-square CDF. I'm going to plug in my test statistic of 14.269. We have our obnoxiously big number. Our degrees of freedom was 7. Go down to paste. If you have the older calculators, you're going to go right to this function. Just do 14.269 comma 9999 comma 7. Hit enter, and we have 0.047 would be our p-value. 0.047. So there's our two scores that we want from our calculator. We have our test statistic. We have our p-value. Now we can go back and write out our answer. So when you write out for the answer, first, step one, always your null and alternate. So we have the winning horse's position fits the assumed distribution, and at least one is incorrect. We don't know which one it is. We're just saying at least one is incorrect. We have our alpha level of 0.01, our test statistic of 14.269, degrees of freedom was 7, p-value was 0.047. So our conclusion, comparing the p-value and the alpha level, since, sorry, that's a typo there, it should say since our p-value is greater than our alpha level, we would fail to reject the null. So we fail to reject the null, so we are saying the winning horse's position fits the assumed distribution. The distribution of the position of the winning horse is correct. Position 1 has the highest chance of winning the race. Okay, so just two quick sentences explaining what we see in the distribution. And this is what your answer should look like. Okay, null alternate, alpha level, test statistic, degrees of freedom, p-value, and then your conclusion. Okay, so this is everyone's answer should look very similar. There's one more look at the steps of finding your p-value. So that would be it for Chapter 9. Okay, try the practice problems, and the grade assignment will be shortly after.